Hi everyone, I am Shubham. Welcome back to my channel Algo-Driver, and I hope you guys are doing well. So without wasting time, let's get started with our new problem. Okay, today's problem is lowest common ancestor of a binary tree. Okay, let me first go through the problem statement. It is saying, given a binary tree, find the lowest common ancestor LC of two given nodes in the tree. According to the definition of LCA, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. Okay. 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 So there are a few possibilities. Okay, I understood the problem. Let me show you the diagram. So, what are the given? Only P and Q are given. Okay. So let me. Okay. Mark it. Okay. So as you can see, I've already drawn the binary tree. Now what our problem statement is saying, you will be given P and Q, any node, that can be any node. So let's consider first this P and this is Q. Okay, so what is the LCA or lowest common ancestor of this binary tree? So obviously it would be 12. 12 will be the LCA of this two node. Because this is the common ancestor and this is the lowest. Now it is very easy to understand. Now I'm showing you one different problem. Suppose this is P and this is Q. So for this, what will be the lowest common ancestor? Now as you can see here, it is saying where you allow a node to be descendant of itself. So for Q, what is the lowest common ancestor, which is P? Okay, and for P, it can be itself. So this 4 node is the LCA of this P and Q. Okay. So I hope you understood the problem. So like if you consider P here, okay, P and Q. So what will be the LCA? Now LCA will be this node, the lowest common ancestor. It's easy. Let's was like once I start coding, I will get to understand the bit more. Okay, let me do it. First, okay, let's drag it to here. Okay, so I'll start with the base case. So if root is equals to null, then return null, nothing. Now our another base case will be like when it reaches when it like, okay, so you are here and this is P and this is Q. Okay, so if you traverse to like on the left part, so if like it is able to find the value, then it should return the node. So how we're going to put it? So if this root val equals to P or root val is equals to Q. Obviously, we need to use the like P is pointer. Now we need to get the value. So it's we are checking the value. Now if it is able to get the value, like if it is able to find the like P is given 4 and it is able to find the 4, then it should return this node. Like 4 it should return. So just return the root node. Root. Now we'll be doing the recursive 2 calls, like for left and right. So let's point out left sub equals to root of left P P and Q. Same for right call. Right subtree. Okay, and we're going to store it in this node. Okay. Now, once this two recursive call is done, so what does it mean? Suppose, okay, suppose this is P and this is Q. Okay. Now, first it would go left and go left. Okay, it has found this 10 node, so it will return 10. Okay. Same for, so once it will return the 10, it will go to right. Okay, found it, so it will return 3. So once we get the both left and right call, it means it has found the LCA. Now go to our code. If left is not equals to null, right, and right is not equals to null. So what does this mean? If both are not null, then it has found the root node, I mean the LCA, obviously. So it should return this 4, because we are going to ultimately return this 4. So return root. Okay. Now what if there can be other two cases? Okay. What if, okay, so we are at here, okay, and if it and P is given, P is given as 4, the Q is given as 3. Now we have started from this node. So for this 2 node, the for LCA would be 4. So it has returned 4. But from this tree, it would return null, right? So ultimately, what should this root node return? It should return 4. So from left subtree, we are getting not null, and right, we are getting null. So let's put it in code. Else if from left tree, we are getting not null, and from right, we are getting null. So it means there is something on left, so return left. Same for the right part. Like if right is not null and left is null, then it should return right subtree, and else return null. It means like if both returns nothing, right? Yeah. Like if it is also return null and it is also return null, then just return null because the LCA is not present. Now let's run this. Okay, there is some issue. 25. Let's see. I have found the problem. This is should be presented. Okay, it is working. Fine, great. Okay, so for this, the time complexity will go off in and space complexity will go off in because of the recursive stack space. And the time complexity off in because each node we are traversing at once. Yeah. Okay. This is the problem for today. Good day. Bye. See you on the next video. Bye.